Welcome to the DIY Honda Garage channel. The error code DTC P0045 indicates a malfunction within the turbocharger wastegate control actuator circuit, specifically in the 2017 to 2022 models of the Honda CRV. The turbocharger wastegate control actuator is a vital component that regulates engine boost pressure by controlling the flow of exhaust gases into the turbine. If the actuator fails or malfunctions, it can lead to performance issues, such as reduced power and efficiency. The actuator is located near the turbocharger and is connected to the powertrain control module, PCM, which manages various engine functions. To address this issue, it is essential to follow a systematic troubleshooting process that involves verifying the problem and carefully checking the wiring and connections associated with the actuator. DTC P0045 reflects a malfunction specifically in the actuator circuit of the turbocharger wastegate in your Honda CRV. The actuator is responsible for controlling the wastegate, which is critical for maintaining optimal engine performance by regulating boost pressure. It acts based on commands from the PCM, allowing the vehicle to manage power output and fuel efficiency effectively. This actuator is typically located adjacent to the turbocharger itself, making it accessible for maintenance and repairs. If it's malfunctioning, it can result in elevated exhaust gas temperatures, reduced fuel efficiency, and potential engine damage if not addressed. Understanding the components and their connections is crucial before diving into the troubleshooting process. Several possible causes may trigger DTC P0045. The most common issues include a shorted wire or an open circuit in the wiring that connects the turbocharger wastegate control actuator to the PCM. These faults can lead to insufficient power being sent to the actuator, resulting in its failure to operate correctly. Additionally, poor electrical connections at the actuator or the PCM can hinder proper circuit functioning. Finally, a malfunction within the actuator itself could be responsible for the error code, implying that it may need replacement. Each potential cause must be examined systematically to narrow down the actual problem effectively. Symptoms associated with DTC P0045 can manifest in several noticeable ways. One of the most evident symptoms is a significant reduction in engine power, particularly during acceleration, as the wastegate control actuator fails to manage boost pressure correctly. Drivers may also observe increased fuel consumption, translating into more frequent visits to the gas station. Additionally, the check engine light, CEL, will illuminate on the dashboard, alerting the driver to a stored trouble code needing attention. It's essential to address these symptoms promptly to avoid further engine complications caused by the malfunctioning turbocharger wastegate control actuator. The first step in troubleshooting DTC P0045 is to verify the problem through a series of actions. Begin by turning the vehicle to the on mode to prepare for diagnostics. Following this, use the Honda Diagnostic System, HDS, to clear the existing DTCs. This step ensures that we work with a fresh set of data for accurate diagnostics. Once cleared, turn the vehicle to the off/lock mode and restart the engine, holding the RPM at 3000 mpm without load until the radiator fan activates. This procedure allows the system to calibrate and may refresh the readings from the turbocharger wastegate control actuator. Finally, check for any pending or confirmed DTCs using the HDS again to see if P0045 reappears, which helps determine if more in-depth troubleshooting is necessary. For troubleshooting step 2, turn the vehicle to the off/lock mode to ensure all systems are inactive before proceeding. Next, jump the short circuit SCS line using the HDS and wait for more than 1 minute. This process allows the diagnostic system to reset and prepare for more accurate readings. Following this, disconnect the specified connectors, the Turbocharger 5P connector, and the PCM Powertrain Control Module Connector E, which consists of 80 pins. The next critical action is checking for continuity between the established test points. Test point 1 is the female terminal number 5 on the turbocharger connector, and test point 2 is the body ground. If continuity is confirmed, it indicates a short in the WGMTR1 wire leading to repair action. In troubleshooting step 3, you will perform a similar check for the WGMTR2 minus line. Maintaining the vehicle in the off, lock mode is crucial. Ensure the turbocharger 5P connector and the PCM connector E, 80P, are both disconnected. You will check for continuity between test point 1, which is female terminal number 1 on the turbocharger connector, and test point 2, the body ground. If you find continuity in this case, it confirms a short in the WGMTR2 minus wire, indicating an urgent need for repair. If no continuity is detected, you will move on to the next troubleshooting step. Each of these checks is essential for isolating the source of the malfunction. In troubleshooting step 4, you'll conduct an open wire check on the WGMTR1 plus line. Keep the vehicle in the off lock mode and ensure that the turbocharger 5P and PCM connectors are disconnected. At this point, check for continuity between test point 1, female terminal number 5 on the turbocharger connector, and test point 2, which is pin number 26 on the PCM connector E, 80P. If there's continuity between these 2 points, it indicates that the wiring is intact, allowing you to proceed to the next troubleshooting step. However, if continuity is lacking, you will need to perform repairs on the WGMTR1 plus wire. Identifying and repairing these issues is a pivotal part of restoring vehicle functionality. In troubleshooting step 5, the focus shifts to checking the WGMTR2 line for any open wires. Maintain the vehicle in the off-lock mode as before, ensuring disconnection of both the turbocharger connector and the PCM connector. For testing, measure continuity between test point 1, which is female terminal number 1 on the turbocharger connector, and test point 2, pin number 25, on the PCM connector E, 80P. If continuity is confirmed, it suggests that the circuit is functioning correctly, and you can advance to the following step. Conversely, if there is no continuity, this indicates an open in the WGMTR2 wire, necessitating repairs to restore the circuit integrity. Each step is critical for accurate diagnostics and eventually resolving the DTC. In troubleshooting step 6, the objective is to check for continuity between the WGMTR1 plus line and the WGMTR2 minus line. As in previous steps, ensure your vehicle is in the off lock mode. It's critical to keep both the PCM connector E, 80P, and the turbocharger 5P connector disconnected for an accurate reading. Measure continuity between test point 1, female terminal number 1, WGMTR2, and test point 2, female terminal number 5, WGMTR1 plus. If continuity exists, this indicates a possible short circuit between these 2 lines that need immediate repair. If continuity is absent, proceed to the next inspecting step to further diagnose the malfunction. In troubleshooting step 7, you will conduct measurements on the Turbocharger Wastegate control actuator's internal circuit. Ensure the vehicle is situated in the off-lock mode, and both the Turbocharger 5P and PCM connectors are disconnected. You need to measure the resistance between test point 1, the female terminal number 1 from the actuator side, and test point 2, the female terminal number 5 from the actuator side. For a normally functioning actuator, the resistance should measure approximately 1.2 ohms to 1.0 kiloohms. If your measurements fall within this range, the actuator is functioning correctly, and you can move on to the next step. However, if resistance readings differ substantially, it indicates a malfunction requiring replacement of the turbocharger actuator. In the final troubleshooting step, you will again check the turbocharger's wastegate control actuator circuit, focusing on the potential for a short-to-ground issue. Ensure the vehicle remains in the off-lock mode and that the PCM and turbocharger 5P connectors are disconnected. At this stage, you will check for continuity between the female terminals of the actuator side, specifically between test point 1 and test point 2, while also checking against body ground. If continuity is identified in this case, it suggests a short that would require replacing the turbocharger actuator. Conversely, if no continuity is detected, it is indicative that the actuator circuit is functioning correctly, suggesting that the DTC may stem from other diagnosed issues or possibly a malfunctioning PCM, which may need substitution. After completing the troubleshooting steps and undertaking any necessary repairs, it is crucial to perform a final verification to ensure that the repairs are successful. Begin by checking the DTCs again, using the HDS to confirm that P0045 is no longer present. If any remaining codes persist, this may indicate further issues requiring additional investigation. After clearing any DTCs, run the engine once more to monitor its functionality. Ensuring that everything operates correctly signifies that the repair has been successful and the turbocharger wastegate actuator circuit is functioning as intended. Conducting this step ensures that you have thoroughly addressed the underlying issue and that the vehicle operates at its optimal performance. Preventive maintenance is essential in avoiding issues related to DTC P0045 and ensuring the longevity of the turbocharger wastegate control actuator and its associated wiring. Regular checks on the wiring and connections will help identify potential weak points or wear that can lead to future failures. It is advisable to monitor engine performance routinely, specifically focusing on signs of power loss or inefficient fuel consumption, which could reveal underlying actuator problems early on. Additionally, ensuring that all electrical connections are secure and clean will promote effective communication between the actuator and the PCM, ultimately enhancing engine performance. Engaging in these preventive measures can save the hassle and costs associated with unexpected repairs, maintaining the optimal functionality of your Honda CRV. In conclusion, DTC P0045 signifies a specific malfunction within the turbocharger wastegate control actuator circuit in Honda CRV models from 2017 to 2022. Understanding the causes of this DTC, such as wiring issues, poor connections, or actuator failure, is critical for effective repairs. The systematic troubleshooting process outlined provides a comprehensive approach to diagnosing and resolving the malfunction. Each step plays a pivotal role in pinpointing the issue and confirming successful repairs. Preventive measures should not be overlooked, as they are essential for maintaining optimal operational performance and avoiding future issues. By integrating these insights and practices, you can ensure that your Honda CRV remains efficient and reliable for years to come. Please like and subscribe to the channel. See you next time.